Hey guys, how's everybody doing today? We're going to be looking at some of the properties with quadratic functions in this video. So we're gonna look at a whole bunch of stuff, just a big collection of different things to do with quadratic functions. So let's just jump in. So we've got a rule here, or an equation, where we want to try to determine some properties. So very first thing I would do if I were you is try to figure out where the vertex of the function is. And remember, the vertex is kind of the starting point. So with a if you had like a parabola here, then the vertex is just that starting point down there at the bottom, that minimum point. Or if it's the other way around, then it's that top point. Anyway, that's what we're going to be trying to look for. And we've got a little math rule that we can do to figure out what the x value for that is. And here's kind of the equation we use. It's negative b over 2a. And that will give us, not 25, 2a. And that will give us the x coordinate of the vertex. So we can figure that out using the rule. The equation has to be written in standard form, like this equation is over here. And the coefficient of the x squared is the a. The coefficient of the x is the b. And then the constant over here is the c. All right? So if we want to figure out the x coordinate, it's negative b. B is, over here we can see b is negative 3. So negative b would be positive 3. So the x coordinate is going to be positive 3 over, and then 2 times a. A is 3 halves. We can see that. So 2 times 3 halves would be 6 halves, which reduces to 3. So x is going to be 3 divided by 3, which is just 1. So our x coordinate for our vertex is just 1. Now, to figure out what the y coordinate is, we can just take 1 and figure out what the function solves to when we substitute 1 into our equation, or into our rule. So we'll figure out what the function is when x is 1. So we can do that. So our y is going to be 3 halves times 1 squared minus 3 times 1 minus 1. So we can do that real quick. 3 halves times 1 squared is just 3 halves. Minus 3 times 1 is just 3 minus 1. So we have 3 halves minus 3 minus 1. So let's see how we could do this. I guess we'll just go ahead and use a calculator. We know 3 halves is 1.5. Minus 3 minus 1 is just negative 2.5. So our y, whoops, that's not what I wanted to do. Our y is just going to come out to be negative 2.5. So if we mark that on our graph over here, our vertex is going to be at 1, or let's say every square is half a point. So every 2 squares is 1. So x is 1, and then y is negative 2.5. So that'd be right, well, maybe that wasn't a good idea. It's all the way down here. 1, negative 2.5. So right here is our vertex. If every block is half, 0.5. Every little block is 0.5. So this is 1, this is 2, this is negative 1, negative 2. Then that's our vertex. Okay. All right, so that's how to find the vertex, and that's, once you get the vertex, you're like good to go. So just remember, to find the x coordinate, it's just negative b over 2a, and then take that value for x, substitute it into your rule, and you'll figure out what y is. All right, and that'll give you your vertex. All right, the next thing we want to look at is the axis of symmetry. So the axis of symmetry, let's see. So this graph is going to look something like this. But the axis of symmetry is just the line that runs right down the middle of our graph for our parabola. And the way we can write that is, and we'll say axis of symmetry. The axis of symmetry is just going to be x equals whatever the x-coordinate of your vertex was. So since the x-coordinate was 1, we can see right here, since the x-coordinate was 1, the axis of symmetry is just x equals 1. Right, so we figured out the vertex, we figured out the axis of symmetry. And just remember, that's why we figure out the vertex first, because then things just start falling into place. It also says find the minimum or the maximum value. The minimum or the maximum value is just going to be equal to your y-coordinate. So you're seeing why we found that vertex. In this case, we have a minimum value because down here at the vertex, right down here at the vertex, it doesn't go any lower than that. The graph doesn't go any lower. It goes all up from there. So we have a minimum at y equals negative 2.5. So our minimum, we'll say this is our minimum in this case. Our minimum is negative 2.5. All right. It also says to describe the domain and range of our function. The domain for all of our quadratic functions, for all of our parabolas, it's always going to be all real numbers. Okay. Let me see if I can make a little more space here. So our domain is just always going to be all real numbers. All right. But our range, in this case, notice that our quadratic function doesn't go below y equals negative 2.5, right? That vertex is the lowest point it goes, and then it goes up from there. So our range is going to have to be y has to be greater than or equal to negative 2.5. Negative 2.5. Again, we're getting that from the vertex. The range has to be greater than or equal to negative 2.5. And then it says where is the function increasing and decreasing. So as we move from right to left, or I'm sorry, from left to right, as we move from left to right, the function decreases until we get to x equals 1, right? So it decreases down until we get to x equals 1, and then it begins to increase for x is greater than 1. Okay, so for x less than 1, it's decreasing, and for x greater than 1, because here's 1 right here, this is x equals 1. So for x less than 1, for all the values to the left of that, it looks like our function is decreasing, and for all the functions greater than 1, it looks like our function is increasing. And I think that's the last thing that we had to really talk about here. So a lot of things to look at. I would say, guys, that you maybe want to plug this into a graphing calculator or into Desmos to check your answers, just to make sure that your graph is in the right place. I know that Desmos will actually figure out the vertex for you. It gives you like a little point, you can just hover over it. So you can use that if you want to kind of confirm your answers. But once you get the vertex, it really is pretty easy from there. I want to show you one more thing before we call it a video. Let's see. So if you have a function written like this example number 4, then we can also figure out what the x-intercepts are for this function. It's really easy. The x-intercepts are just going to be the opposites of these numbers right here. So if you have the function factored, or as listed as factors like this, then the x-intercepts are really easy to find. They're just the opposites of those numbers in there. So we have one at -4, and we'll just say these go by ones this time. So 1, 2, 3, 4. So we have one x-intercept here at -4, and then we also have an x-intercept at +3. 1, 2, 3. So we have one right here. Okay. So our graph, let's see. Graph is going to be our axis of symmetry is like right in here, right in between those two dots, and so our graph is going to look something like this. Oh, that's not the best drawing ever. Let me try one more time. We'll go in a different color. Okay, that's a little bit better. So the x-intercepts are just where the graph is intercepting or touching the x-axis. So that's the x-intercept. And the axis of symmetry, notice, is right in between those two. It's like directly in the middle. So we could figure that out real easy. So the axis of symmetry is just going to be our two intercepts, the average of our two intercepts. So we had -4 and 3, and we can just divide those by 2. So -4 plus 3 is -1. So our x-intercept is at -1/2. Right? -4 plus 3 is -1, divided by 2 is -1/2. And we can see that, like our little blue line right here, it looks like it is crossing, or the axis of symmetry is right there at x equals -1. So that's our axis of symmetry, and then our x-intercepts are pretty easy to find if it's factored. Anyway, guys, I hope this helps with some of your problems. But just remember, I would say for these problems, get your vertex first, and then you should be able to find out everything else about the function. Guys, if you have any questions, leave them in the comments or send me a message. Always be happy to get back with you on those. But otherwise than that, y'all have an awesome day, and I'll see you in the next video.